Technology. Yesterday, we have started with the beam reactions, and after completing of all theory, types of load, types of beam, and types of support, here we are solving one question. We have to calculate the support reaction. Here we will solve few more questions today, and today we will finish this equilibrium lesson, and after that, we are going to start the friction. The next question, sum number 2. This was the sum number 3 which was solved. Here, there is one horizontal beam bar of the G. Here, at point A is supported with a of support. Carries the UDL for 4-meter length, and magnitude of the intensity of this UDL is 5 kilonewton per meter. At this point, when vertically downward force is there, everything is going smoothly or not? Am I audible?
Yes, sir.
So this load is 25
There is
kilonewton.
low. My voice is a bit low.
What happened? What happened?
सर आपका वॉइस क्लियर नहीं है, एको हो रहा है.
Hello, all of you are facing the same difficulty of voice?
Yes, sir.
Yes,
Yes,
sir.
yes, sir.
Hello.
Yes, sir.
Till it is the same.
No, sir.
No, sir.
No,
Now,
sir.
is it comfortable now?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Okay. Now this is one beam which carries at left end there is a hinge support. Then it carries the UDL over the length of 4 meter. Then there is a point load of 25 kilonewton here, and after 2 more meter. This is the part of this beam only. This is the projected part of the beam only. Okay, and on this projected part, one inclined force is there. You don't have to bother about that. As usual, you have to solve. Okay, here this is 30 kilonewton. Incline at an angle of 40 degree with horizontal. This point is F, this is E. This horizontal distance EF is 2 meter, and this vertical distance DE is 1.5 meter. Okay, this force is acting on the projected part of the beam itself. Clear? This is a part of this body itself. Clear? No need to transfer this force from this point to on this beam. Keep it there only. Doesn't make any difference. Okay, and at point B, there is a roller support. Here, this dB distance is 4 meter. You have to calculate the support reaction. Okay. Now, what is the first step to calculate the support reaction? The first is to draw the free body diagram. Here in free body diagram, I am drawing free body diagram on this figure itself. Here, FBD of beam. I am not redrawing the figure, FBD of beam. Here now, what you have to do in the FBD? Here in FBD, instead of support, you have to show the support reaction. So instead of this point, support A, hinge, Here you are supposed to show the two component of reactive forces. This is the horizontal component at A, vertical component of A. Let assume HA is towards right, VA is upward. Here, so instead of support, you have to show the support traction. Similarly, at point B, there is a roller. We know that at roller there is only one unknown, and the reactive force at roller is always perpendicular to the supporting surface. Here, supporting surface is horizontal. Listen, this gap is means there is a roller. Okay, yeah. So don't get confused. There are different conventions to show the roller support. At the roller support, the reactive force is perpendicular to the supporting surface. This supporting surface is horizontal, so reactive force will be vertical. So this is RB. Here I am writing V and here I am writing RB. The reason is that here there is no any horizontal component of this reaction at point B. ये zero है. And since this HB is zero, this vertical component of the reaction at point B itself becomes the resultant reaction. That's why I am writing it as a RB instead of VB. Okay. Whereas here two components are there. Here और ये दोनों का जो resultant आएगा that will be RA. Understood? Here, but for initially you have to consider these components only to apply the condition of equilibrium. So first step is to draw the FBD, and in that FBD, instead of support, I have shown the support reaction. Now you have to convert this distributed load into equivalent point load. Now this distributed load is intensity is 5 kilonewton per meter spread over a length of 4 meter. So equivalent point load will act at the midpoint of this length. They are directed toward the base of that semicircular pattern. Means this distance is 2 meter. This is 2 meter. Here and in the magnitude of that equivalent point load is 5 into 4. It is 20 kilonewton. In case of the UDL, it is the product of the intensity and the length over which it is spread. Now, once you convert this UDL into equivalent point load, consider that equivalent point load only in further calculation. No need to consider this UDL. Here, because we have converted it into equivalent point load. Here, then this 30 kilonewton force is the inclined force. Let resolve it into two components. Here, this is 30 cos 40. This is 30 sine 40. Now apply the three conditions of equilibrium, you will get the three unknown. Now very simple, remaining part. Here using condition of equilibrium. Now since it is a general force system, you have to use the three condition of equilibrium. Here I told you that in that case first use the moment. And where to take the moment, which point to be selected as a moment center, कहाँ पे लेने का moment, कल बोला था मैंने,
जहाँ पे सबसे कम अननोन हो सर,
जहाँ पे सबसे ज्यादा अननोन हो,
ओके
कम नहीं. ओके, ये क्योंकि हम लोगों को नंबर ऑफ अननोन्स एलिमिनेट करने का है, सो दैट अपना इक्वेशन सिंपल होगा. अगर ये इक्वेशन में 3 अननोन है यार, वही अगर ये इक्वेशन में 1 अननोन है तो कौन सा इक्वेशन इजी जाएगा सॉल्व करने के लिए, जिसमें 1 अननोन है. ये मतलब हम लोगों को नंबर ऑफ अननोन्स एलिमिनेट करने का. वी हैव द अदर इक्वेशन आल्सो जिसमें वो अननोन्स आ जाएंगे बाद में. Okay, so to make the equation simple, to make the calculation simple, we have to select the moment center at that point where maximum unknowns are meeting. Yeah, so A is the point where maximum unknowns are meeting. So let's take the moment at point A. Here, now take the clockwise moment, negative, anti-clockwise positive. We are taking the moment about point A. So keep one finger at A. So moment of HA, VA becomes 0. Both are passing through A. Moment of this 20 is clockwise, so minus 20 into 2. Moment of this 25 is clockwise, so minus 25 into 4. Now to take the moment of this 30, let's take the moment of this 2 component. Then the moment of this sine component about point A, clockwise, so minus 30 sine 40, ये होगा force, into how much is the perpendicular distance of this 30 sine 40 from A, this much will be the distance, perpendicular distance. How much is that? 4 plus 2 plus 2, that is 8. Then moment of this cos component, the moment of this cos component is anti-clockwise, move in the direction of the force and turn toward the moment center, so anti-clockwise, so plus. It is 30 cos 40 into how much is the perpendicular distance? The perpendicular distance of this cos component from A is this vertical distance, which is equal to 1.5. And moment of this RB upon point A is anti-clockwise, so plus RB into how much is the perpendicular distance? 4 and 4, 10. 4 and 4, 8 plus 2, 10, which is equal to 0. Here don't forget to write this 0. Complete the equation. Now solve this equation. In this equation only one unknown is there, that is RB. You will get that RB. अगर पॉजिटिव आता है तो assume direction is correct, अगर नेगेटिव आता है तो assume direction is wrong. Here use solve function and tell me the value of RB. 1 मिनट में आंसर आएगा. How much? कितना आ रहा है? How much is the answer? Hello?
सर
Am I
Yes,
audible
sir.
or not?
Sir,
हाँ बोलो.
25.97.
25.97, right? Okay, it is 25.97. This answer is positive. Here means the assumed direction is correct. Here we have considered that RB is vertically upward. All forces are in kilonewton, so this answer will also be in kilonewton. Now use other condition of equilibrium. Let's consider summation of fx equal to 0. पहले condition लिखो and then write the equation. Let's start from left. It is a summation of only forces. Force towards right positive. So HA. Here then which is the horizontal force? This force. Minus 30 cos 40 equal to 0. From this one you will get HA. HA equal to 30 cos 40. How much is that?
22.9.
22.98 kilonewton. Now this is also positive. It indicates that HA, assumed direction of HA is towards right. So HA is horizontally towards right and highlight this. Then use summation of Fy equal to 0. If I use summation of Fy equal to 0, summation of all vertical component of forces, or summation of all vertical forces. Upward force positive, downward force negative. So Va upward, so positive. Minus 20, minus 25, minus 30 sine 40, plus Rb equal to 0. Here, this is upward, that's why plus. Now, its magnitude is 25.97. Substitute this Rb equal to 25.97 here and get the value of Va. Again, use solve function and get the value of Va. After getting the Va, calculate the resultant reaction at A. Resultant reaction at A. So this Re equal to under root of Ha square plus Va square. It is the resultant of these two. It is the resultant reaction at point A. And let's see the inclination with horizontal is theta. Yeah, so this theta equal to tan inverse of Va upon Vha. Just substitute the value and get the answer. Got the answer?
72.4.
Is it Va?
Yes, sir.
Va कितना आ रहा है?
72.4.
Answer is 38.
Yes, sir.
Yes, sir.
38.31.
38.31.
38.31.
38.31. Here, you may not have considered this 25.97. Okay, then calculate this resultant reaction and this angle. Always calculate the resultant reaction and its direction at the hinge support. Here, hinge support पे पहले components मिलेंगे and with help of these two components, you have to calculate the resultant reaction at this angle. Here, that is for homework. Let's start the next sum. Sum number 9. Here, there is a L-shaped beam is there. Here, such type of L-shaped beam is there. Okay. Here on this vertical part, on this vertical, how much is that? I'm not sure about that. Whether this AB distance is 1 meter or 2 meter. Here, let's consider it as a 3 meter. Okay, and there is a UVL. Which type of load is this? It is a UVL, triangular load is there, acting towards right, horizontally towards right. This is B, this point is D, where there is a hinge support. This total distance is BD, distance is 3 meter. And then this from D to C, there is a UDL. And at point C, there is a roller. The intensity of this UDL is 1 kilonewton per meter. And this distance is 6 meter. Okay. Now at this point A, yes, on this L-shaped beam, at this point A, one string is connected. Listen carefully. One string is connected, inclined at angle of 30 degree. This end of the string is passing over this pulley. Clear? And it is suspended one weight. This weight is 3 kilonewton. It is given. Actually, if this weight is 3 kilonewton and if it is in the equilibrium, if it is in the state of rest, if this weight is in the state of rest, listen carefully. When any weight is suspended with the help of some string and this weight is in equilibrium, here if it is in the state of rest, अगर मैं उसका FBD लेता हूँ, तो weight act vertically downward and this is the tension in the string. If I apply the condition of equilibrium, summation of Fy equal to 0, I will get T equal to W, isn't it? Clear? So whenever the string, this weight is in the equilibrium and vertically downward, the tension in the string is equal to that weight. Clear? मतलब ये string में का tension कितना होगा? It is 3 kilonewton. Other important thing, मैंने आपको resultant में बोला था. Other important thing. Here, whenever any string passing over the pulley, you have to always consider that the pulley is frictionless. Whenever any string is passing over the pulley, frictionless pulley, then the tension on either side of the string is remain same. Here, ये tension अगर T है, तो this will also be T acting along the string and away from the body under consideration. Here, important thing is that when the string passing over the pulley, the tension on either side is same. Here we are assuming that it is a frictionless pulley. Even in friction also, you have to assume that the pulley is frictionless because this belt friction or the pulley friction is not in your syllabus. You have to always assume that the pulley is frictionless, and if the pulley is frictionless, the tension on either side will be same. If there is a friction between the belt and the pulley, here this tension won't be equal. Okay, and it is desirable to have the friction in the belt and the pulley. यार अगर यहाँ पे फ्रिक्शन नहीं होगा तो पुली और बेल्ट के with help of belt and the pulley we cannot transmit the motion and the power. That motion and the power here in floor mill you must have observed. Here floor mill में belt and pulley रहता है. Here so in floor mill the power and motion is transmitted from the belt to the pulley or from the pulley to the belt just because of the friction. Understood? But here we have यहाँ पे हम लोगों को कुछ power transmit नहीं करने का है. So here we are assuming that it is a frictionless, and when it is a frictionless, the tension on either side is same. Understood? Here, so now in FBD, what I am going to do, since the tension in this string is 3 kilonewton, and I am going to consider the FBD of this rod, L-shaped rod का FBD consider करने वाला हूँ. Now, since I am considering the FBD of the L-shaped rod, you have to just show the forces acting on that rod or on that beam. Here, so instead of this pulley and all these things, here I am going to show the force acting on this rod at point A. And how much is this? It is equal to the 3 kilonewton. This tension in this string acting, now this body is under consideration. So it is acting along the string and away from the body. So this force is 3 kilonewton, inclined at an angle of 30 degrees. You don't have to consider this. Here, so this is the force acting on this beam. Here, the second force is the equivalent point load for this UVL. It is a UVL. Here, whose intensity is 2 kilonewton per meter. Here I have not written that, it is 2 kilonewton per meter and it is spread over a length of this vertical arm on 3 meter. Here, so UVL को equivalent point load में कैसे convert करेंगे? So we know that the equivalent point load for the UVL acts at the centroid of that triangle. कहाँ पे act होता है? It acts at the centroid of the triangle, directed toward the arrow. Arrows are towards left, so it will also towards left. It is acting at the centroid of that triangle. Now, base of the triangle is 3 meter. Here, so the distance of that centroid from this right angle corner of the triangle, this distance will be b by 3. This distance will be 3 by 3, which is equal to 1 meter. So that equivalent point load will act at a distance of 1 meter from the base. Here, have you understood this? Here, I have converted that triangular load into an equivalent point load, which will act at the centroid of the triangle. Now, what will be the magnitude of this equivalent point load? It is equal to the area of this triangle, which is half into base is 3, and this height was 2. So, which is equal to 3 kilonewton. Any doubt? वो UVL equivalent point load में कैसे convert किया समझ में आया क्या आपको?
हाँ sir.
Yes, sir.
Okay. Now, next, at point D, there is a hinge. So at hinge, you have to show the two components of reactive forces. Consider any direction. This is HD, this is VD. Horizontal component of reaction at point D, vertical component of reaction at point D. फिर calculation के बाद में यहाँ का हम लोग resultant reaction calculate करेंगे, depending on the direction of HD and VD. Then this UDL converted into equivalent point load. It's spread over a length of 6 meters, so equivalent point load will act at the 3 meter. And what will be the magnitude? it is 1 kilonewton per meter spread over a length of 6 meters. So 1 into 6, that is 6 kilonewton. Here, once you convert it into equivalent point load, forget about that UDL. And then this roller support, so show only one component of reactive forces perpendicular to the supporting surface. Supporting surface is horizontal, so this component or this reaction is vertical. Let assume it is vertically upward. Clear? Now just apply the three conditions of equilibrium. You will get the three unknowns, HD, VD, and RC. So apply the three conditions of equilibrium. Write down the equation. Before applying the condition of equilibrium or to apply the condition of equilibrium, we need to resolve the inclined forces. अभी इसमें सिर्फ ये एक ही force incline है, so I am going to resolve it. Yeah, this will be 3 cos 30 and this is 3 sin 30. I hope that all of you are comfortable with the resolution now. Okay, here now you have to write down the equation. Here use first condition of equilibrium. Here algebraic summation of the moment of all forces about any point is equal to 0. You can take about any point. लेकिन मैंने बोला था आपको कि ऐसा point select करो जहाँ पे maximum unknowns हो. Okay, so I will select D as the moment center. So let's take the moment of all the forces about point D and equate it with 0. यार यहाँ पे moment ले रहे हैं इसलिए HD VD जो unknowns है वो eliminate हो जाएंगे, आपको RC मिल जाएगा directly. Okay, so how you are going to tell me? Who is going to tell me the equation? Suyash Dadvi, roll number 12. Suyash, are you there? Suyash. Suyash Dadvi, roll number 12. A12. Harsh. A16. Harsh. Unmute yourself. Harsh. A18. Omkar.
Yes, sir.
Okay. Tell me the equation. We are taking the moment about point D. यहाँ से start करने का एक एक force का moment लेने का about point D और लिखने का. Here clockwise है तो negative, anti-clockwise है तो positive. Let's start. Tell me the equation.
सर स्क्रीन नहीं दिख रहा है.
हाँ दिखाता हूँ. हाँ अभी दिख रहा है.
Yes, sir.
Okay. Now tell me moment about point D. Let's start from A. चलो फटाफट. Let's take the moment of this 3 sin 30 about point D. Clockwise आएगा या anti-clockwise आएगा? Moment of this 3 sin 30 about point. कैसे anti-clockwise आएगा?
Anti-clockwise.
क्यों? This is the D point. और
Sorry, sir.
यहाँ पे ऐसा act हो रहा है.
Clockwise.
Here it is a clockwise. Move in the direction of the force and turn toward the moment center. It will be the clockwise. Clockwise है इसलिए minus.
Minus 3 sin 30.
Correct. Into perpendicular distance. ये force का perpendicular distance D से कितना है? If required, you can extend the line of action and find out the perpendicular distance from D. कितना है?
1.5.
1.5 कैसे? कहां से 1.5 दिख रहा है तुझे? ये वर्टिकल कंपोनेंट का परपेंडिकुलर डिस्टेंस फ्रॉम डी, ये डिस्टेंस आएगा कितना है ये?
3 मीटर.
3 मीटर. फिर 1.5 क्यों बोल रहा है? इट इज 3. देन मोमेंट ऑफ दिस कॉस कंपोनेंट अबाउट पॉइंट डी क्लॉकवाइज है या एंटी क्लॉकवाइज है?
क्लॉकवाइज है सर.
क्लॉकवाइज है, सो माइनस. ओके, सो माइनस 3 cos 30 into how much is the perpendicular distance? अभी ये 3 cos 30 का ये हॉरिजॉन्टल फोर्स है. हॉरिजॉन्टल फोर्स का परपेंडिकुलर डिस्टेंस डी से ये वर्टिकल डिस्टेंस आता है. For horizontal force, the perpendicular distance is vertical. Tell me how much is that vertical perpendicular distance?
3 ना?
3. This 3 meter will be the perpendicular distance for that cos component. Here ये दोनों component का movement हो गया. Go ahead. Next force is this 3 kilonewton. Okay, ये 3 kilonewton. Moment of this 3 kilonewton about point D. Here it is anti-clockwise. So plus
3 kilonewton
into how much? यार ये हॉरिजॉन्टल फोर्स है, इसका परपेंडिकुलर डिस्टेंस डी से ये वर्टिकल डिस्टेंस आएगा. कितना है ये?
1.
परपेंडिकुलर 1. इसका मोमेंट हो गया. नाउ मोमेंट ऑफ एचडी एंड वीडी अबाउट पॉइंट डी कितना आएगा? ये
जीरो
दो
आएगा
फोर्सेस
सर.
है, नेक्स्ट जीरो आएगा. नेक्स्ट फोर्स 6 किलो न्यूटन. व्हाट विल बी द मोमेंट ऑफ दिस 6 किलो न्यूटन अबाउट पॉइंट डी?
-6 into
-6 into
6. 6 नहीं 3 सर, 3.
3. And then movement of this RC about point D
Plus RC into
plus RC into
6.
6. Very good. Equal to 0. Here, don't forget to write equal to 0. Now, in this equation, only one unknown is there, that is RC. Simplify, you will get RC. Then use other two conditions of equilibrium, you will get HD and VD and finish. Okay. Sum is simple, not that difficult. Only new concept is this. When the string is passing over the pulley, क्या करने का? Here, next condition is summation of fx equal to 0. So it is 3 cos 30 minus 3 equal to, sorry, plus hd equal to 0. From this one you will get hd. Then summation of fy equal to 0. Summation of all vertical forces. Here 3 sin 30 upwards or positive. Then plus vd minus 6 plus rc equal to 0. Here now rc is known to you. So substitute that rc over here and get the value of vd. Then resultant reaction at D. Resultant reaction at point D. So RD equal to under root of HD square plus VD square. And let's calculate its inclination. Theta equal to tan inverse mod of VA upon VD upon HD. You'll get the resultant reaction. Any doubt? This is supposed to be the most easiest part in mechanics. Here 5 minutes में आपका sum होगा. Here provided you should be comfortable with the movement. Okay, finish. हो गया क्या? लिख के हो गया क्या? Shall I proceed further? So we have to finish two more sums. Sum number 10 and sum number 14. Now sum number 10. Again same concept of the pulley and the string. Sum number 10. Okay, it is given that there is one beam. At this end, it is supported with the help of hinge support. This is a hinge support. This one, whether the hinge support is resting on a horizontal surface or vertical surface. Yeah, as usual, you have to show the two component of reactions, horizontal and vertical. Okay. Then on this beam, there is a UVL spread over a length of 3 meter. Magnitude is 15 kilonewton per meter. Okay. Then at this there is one mass. This mass is 100 kilo, weight is 100 kilonewton. One block is resting on this beam whose weight is 100 kilonewton. Yeah. Now इधर ध्यान दो, very important concept. यार अगर ये पूरा block अगर इस पे ही act होता था, yeah, so this entire weight of that block, 100 Newton, would have been act on this beam itself. In APD, I would have shown that 100 kilonewton directly on the beam itself. Its entire weight would have been act on that beam. But here, this block is not only supported by the beam, here, but it is supported with the help of one string also. It is supported with the help of this string also. Here, listen to me. Suppose अगर ये बुक मैं ऐसे सरफेस पे रख देता हूं, तो उसका जितना वेट है उतना पूरा वेट मेरे हैंड पे आ रहा है, isn't it? Here, let's consider the weight of that book is 10 Newton. So entire 10 Newton force is coming on my hand now. Here, लेकिन अगर मैं ऊपर से भी उसको अगर ऐसा कुछ सपोर्ट देता हूं, here if I give some support here from the upward direction also, here, so because of this support, some of the weight is shared by that support. Here, means in that case, the entire 10 Newton won't act on that support. Here, it is shared by that string some weight. Okay, यार, so this is also one kind of support to this. मतलब ये जो ब्लॉक है, इसको दो सपोर्ट है. एक नीचे से सपोर्ट है जो रिएक्टिव फोर्स अप्लाई कर रहा है, दूसरा ये टेंशन है. Understood? Yeah. So here, because of this tension, the entire 100 Newton force won't act on the beam. Then what is given? Here, this string is passing over one pulley. Here, and other end of the string is again connected to the same beam. Other end is connected to the same beam. Here, this beam is supported at end A with the help of hinge, and at another end with the help of string. Here, the string is managed such that the length of that string is managed such that it supports this beam also as well as this block also. Understood? Here. So, this distance of the string from this point is given as 1 meter. This is 1 meter. Then from this point to this point, it is 6 meter. This point is B. And this is 3 meter. This vertical distance is 3 meter. Now, since this is 3 meter and this is 6 meter, here we can calculate this angle. Consider this as a right angle triangle. So, with respect to this angle, opposite side is 3 and adjacent side is 6. Okay. Yeah, so how much is this angle? Tan inverse 3 upon 6. Opposite side or adjacent side pata hai. Yeah, so this angle will be tan inverse of opposite side upon adjacent side. Tan inverse 3 upon 6, tan inverse 1 by 2. How much is that?
26.56.
26.56. So this angle is 26.56. Okay. Now since this string support the beam as well as this block, so it is having some tension. The string will be in tension. Yeah, and this string is passing over this pulley. So tension on either side is same. अगर ये string में का tension T है तो इसमें का भी tension T है. And how to show the tension? I told you that the tension always act along the string and away from the body under consideration. यार अगर आपने ये 100 न्यूटन का ये ब्लॉक का अगर एफबीडी कंसीडर किया तो टेंशन एक्ट अलोंग द स्ट्रिंग एंड अवे फ्रॉम दैट, और पुली का एफबीडी कंसीडर किया तो टेंशन एक्ट अलोंग द स्ट्रिंग and away from the pulley. These two forces are equal in magnitude and opposite in direction. Here एक action है तो दूसरा reaction है. They are equal, opposite and collinear. Here, but in FBD you have to show such that. Here, अगर ये figure में दिखाया है तो मैंने ऐसे दिखाया by double-headed arrow. Understood? Here, now we have to draw the FBD of the beam. Figure समझ में आया क्या आपको? Have understood the figure? Now I am drawing the FBD of the beam. FBD of beam AB. So this is the beam AB. Okay, this distance is 3 meter. Now at point A, there is a hinge. So since there is a hinge, show the two components of reactive forces. Here it is HA and VA. Then from this A to this intermediate point, there is a UVL. So equivalent point load will act at the centroid of that triangle. Here, so centroid of a triangle will be B by 3 from the right angle. So this distance will be B by 3. B is 3. So this will be 3 by 3, that is 1 meter. And magnitude of that equivalent point load is equal to the area of this triangle. How much is the area of triangle? It is half into base into height. Yes, so it is 22.5 kilonewton. This is the equivalent point load for that triangular load. Okay. Here then, after 1 meter here, यार अभी यहाँ पे क्या होगा? We have to show the reactive force exerted by this block on the beam. Okay, so for that, to show the reactive force exerted by the block on the beam, अगर ये string नहीं रहता तो मैं directly 100 kilonewton, 100 Newton I would have shown. लेकिन because of this string, it won't be 100 Newton. Okay, so for that, what I am going to do, I will consider the FBD of the block separately. Let's consider the FBD of the block separately. Here, so this is the block. Which are the forces acting on the block? Here, this is the tension T act vertically upward along the string and upward, and this is the reactive force exerted by the beam on the block. This is what I am denoting it as a R. This is the reactive force exerted by the block beam on the block. Here, since this block and the beam are in contact with each other, the reactive force exerted by the beam on the block and reactive force exerted by the block on the beam, they are equal and opposite. Here, so अगर ये reactive force is exerted by the beam on the block is R, so equal amount of reactive force is exerted by the block on the beam. So this is R. और ये R कितना आएगा तो मैं इसका FBD लेके वो calculate करूँगा. Understood? Here, so which are the other forces acting on the block? ये tension T हो गया, R हो गया, और इसका weight always act vertically downward, 100. Now under the action of these three forces, this block is in equilibrium. All forces are upward, so vertical, so I will use summation of Fi equal to 0. If I use summation of Fi equal to 0, then this is R plus T minus 100 equal to 0. So R equal to 100 minus T. This is the reactive force between the block and the beam. ये दोनों में का reactive force इतना है. Okay, so this R is equal to 100 minus T. They are equal in magnitude and opposite in direction. ये upward है तो ये downward. Here have you understood that? ये समझ में आया क्या आपको? क्या किया?
Yes, sir.
Okay.
Yes, sir.
Then which is the next force? The tension at point B. This is T. ये T और ये T same रहेगा. And this inclination is 26.56. Since we are isolating this beam from all other supports, या तो beam का ही FBD consider करने का है. ये पुली का FBD इसमें नहीं आएगा. Okay, I consider only FBD of beam. Beam को ही isolate किया मैंने. Clear? Now, if you observe this, how many number of unknowns are in this system? कितने unknowns है इसमें? यहाँ पे 2 है और यहाँ पे मिलके एक ही unknown है, that is T. Means all together there are 3 unknowns. Here, HA, VA and T. So apply the 3 conditions, you will get the 3 unknowns. For that you have to resolve this T into 2 components. So this will be T cos 26.56 and this is T sin 26.56. Just apply the 3 conditions. यहाँ पे moment ले लो तो T मिल जाएगा. Use summation of Fx equal to 0, HA मिल जाएगा. Summation of Fy equal to 0, VA मिल जाएगा. Finish. Any difficulty? Question समझ में आया क्या? I am not going to solve. Yeah, this is for homework. Any doubt?
No, sir.
Okay. Now one last question in which there is a fixed support. Okay. As usual, you have to draw the FBD. Only whenever there is a fixed support, how many unknowns will be there?
3.
3 unknowns will be there. So as usual, you have to show the 3 unknowns and you have to solve and get the 3 unknowns by using the 3 conditions of equilibrium. Okay. Here, ये solve करके आएगा ना आपको? Here, try this. Apply the 3 conditions of equilibrium. And keep your notebook ready. Here today I will create one assignment in which you have to submit the class notebook. जैसा है वैसा ही submit करने का है. That is not the additional work. That is your regular work. Here from first day only I am telling you, you have to keep the class notebook properly. Okay, today I will create the and you have to submit the all class notebook. Here centroid you have submitted. Here resultant, kinematic of particle. Here then equilibrium. जितना सम मैंने इधर सॉल्व किया है वो आपके बुक में होना चाहिए. एक्स्ट्रा सम नहीं सॉल्व किया तो भी चलेगा.
सर पीडीएफ बना के ऑब्वियसली सब सबमिशन आपको पीडीएफ बना के ही करने का है. हाँ, सम नंबर 40. Listen, this is one beam. At A there is a fixed support. Then at point B there is one vertically downward force 10 kilonewton. Here from C to D there is a UDL spread over a length of 6 meter. This is 3 meter. This is 2 meter. This intensity is 5 kilonewton per meter. And then from E, DE distance is 2 meter. And at point E there is one moment, one clockwise moment is there. Here this moment you have to take as usual in the moment equation. Okay, directly you have to add it in the moment equation with its proper sign. Here and then EF, on this EF, this is EF, there is a triangular load. Here this triangular load at upward. Here at F, when 20 kilonewton force is acting inclined at an angle of 20 degree with horizontal at point F. Clear? F पे सपोर्ट नहीं है, ये बीम को एक ही सपोर्ट है, that is A, और वो फिक्स सपोर्ट है. Clear? You have to calculate the support reaction at point A. Here, so you have to draw the free body diagram. EF distance is 3 meter. This EF distance is 3 meter, and magnitude of that intensity of that UVL is 6 kilonewton per meter. Yeah, this is the UVL whose intensity is 6 kilonewton per meter. Yeah, so first let's draw the FBD. Let's draw the FBD of this beam. FBD of beam. At point A, there is a fixed support. कितने unknowns आएंगे यहाँ पे? There will be 3 unknowns. Here, one is a horizontal component of reactive force, other one is a vertical component of reactive force, and third one is a reactive moment. Let's denote this as a reactive moment at point A. MA. It is a reactive moment at point A. Here it is a reactive moment exerted by the support on the beam. This reactive moment is similar to this moment. खाली ये moment इधर act हो रहा है, ये moment इधर act हो रहा है. Okay. Here it is a reactive moment. Now for all these 3 unknowns, initially you have to assume the direction. So I am assuming that HA right, VA upward, and ME is anti-clockwise. Here because I am assuming that all the forces, most of the forces are downward. So these downward forces are producing the clockwise moment. Here, so to balance that, the reactive force has to apply the anti-clockwise moment. Okay. Here, then this 10 kilonewton force at point B. Then this is the C point, this distance is 3 meter. Then C to D, this distance is 6 meter. Show the distances properly. Convert this UDL equivalent point load. Equivalent point load will act at the midpoint, spread over length of total UDL is spread over length of 6 meter. So the equivalent point load will act at a distance of 3 meter. And magnitude of that equivalent point load is 5, 6 are 30. Okay, then from D to E, this is 2 meter. And at point E, there is one clockwise moment here, which is 50 kilonewton meter. Here, and on this EF part, there is a triangular load. So equivalent point load for the triangular load act at the centroid of that triangle. यहाँ पे act होगा, ऐसे दिखाओ. It is acting vertically upward. These arrows are upward, so it is acting vertically upward. Okay, and at the centroid of the triangle, the base of the triangle is 3 meter, so centroid will be at a distance of 2b by 3, that is 2 into 3 by 3, which is equal to 2 meter. ये 2 meter है, मतलब ये 1 meter है. Yeah, then what is the magnitude of that equivalent point load? It is equal to the area of this triangle. Here, so it is half into base is 3, height is 6. Here, so which is equal to 9 kilonewton. And at point F, there is one inclined force of 20 kilonewton. So let's resolve it into 2 components. This is 20 cos 20 and this is 20 sin 20. Any doubt?
सर
हाँ बोलो.
ओ 30 किलो न्यूटन है सर वो इंक्लाइन फोर्स.
30 है.
हाँ.
Ah, yes, it is 30. It is 30. Okay. Anything else? Anything else? Now apply the 3 conditions, you will get the 3 unknowns. So first I will use the moment equation, algebraic summation of the moment. Listen to me. This is the algebraic summation of the moment of all forces as well as this moment about point A must be equal to 0. It is the algebraic summation of the moment of all forces about point A equal to 0. This MA and this MA are different. Yeah, this is the reactive moment at A. And this is the algebraic summation of the moment of all forces about point A. 39 Omkar. Omkar. Moment of all forces about point A you have to take, including this moment, these 2 moments. Clear? Now let's start from A. Now at point A, H and V are there, दोनों का moment 0 हो जाएगा. Both are passing through the point A. But at the same point, there is one reactive moment also, which you have to add in this equation directly. Now it is the anti-clockwise, so plus MA. Then moment of this 10 kilonewton force about point A clockwise, so minus 10 into 2. Moment of this 30 clockwise, minus 30 into, how much is perpendicular distance from A? 2 plus 3, 8. Clear? Then at point E1 clockwise moment is there, so minus, which is 50. Directly add करो, उसको multiply distance से मत करो, because itself is a moment. Then moment of this 9 kilonewton about point A, anti-clockwise, so plus 9 into ये फोर्स है तो मल्टीप्लाई करना पड़ेगा डिस्टेंस है. हाउ मच इज द डिस्टेंस? 2 plus 2 4, 4 plus 6 10, 10 plus 5 15. And moment of this 30 sin 20 about point A clockwise, so minus. It is 30 sin 20 into यहाँ तक 15 मीटर आया था plus 1 16. And moment of this 30 cos 20 about point A will be 0 because its line of action passes through A. So this is the equation of movement about point A for all the forces, which must be equal to 0. Simplify this, you will get MA. This is the reactive moment at point A. This is the reactive moment at point A. अगर पॉजिटिव आता है तो assumed direction is correct. अगर negative आता है तो assumed direction is wrong. Any doubt? Have understood?
Yes, sir.
Okay. Then use other two conditions. Summation of fx equal to 0 use करेंगे तो HA मिल जाएगा. Summation of fy equal to 0 use करेंगे तो you will get VA. Here then calculate the resultant reaction at A. RA equal to under root of HA square plus VA square and calculate its inclination. Remaining part is simple. But whenever there is a fixed support, you are supposed to consider the three unknowns for fixed support. Here, sum number 15 is also based on the fixed support. You can try that also. Any doubt? Listen, for exam, you have to prepare only these questions which I have taken here. पहले ये questions करो, इसके बाद में दूसरा questions करो, अगर आपके पास time है तो. Okay, but first clear the concept, and then solve this much questions only, clear, and then solve some extra questions. Understood? Any doubt? Here, this is the end of the equilibrium lesson. Here, next lesson I am going to start as a friction. Here, friction is just extension to the equilibrium. All concepts are exactly similar. यही तीन conditions of equilibrium use करने का है. Only in equilibrium we assume that the surfaces are the smooth surfaces. Yeah, we have shown only normal reaction, but in friction, the surfaces are having some friction, and because of that, there will be the frictional force. Okay, so you have to add frictional force and you have to apply the conditions of equilibrium. That's all. Here, friction is not that difficult. Okay. Any doubt? So after this, I am going to start the friction. Now, since today physics sir is not available, so instead of physics lecture at 10:20, here I will try to take the mechanics lecture. Here I am not committing here, but I will try to take the, because of some urgent meeting or something, I may not take the lectures, but possibly I will take at 10:20. Here, and at 10:20 we are going to start the friction. Don't miss the first lecture. Important lecture है. Theory होगा initially. Okay, thank you. You can leave the meeting.
हेलो सर.
हाँ बोलो.
सर असाइनमेंट के लिए सैटरडे तक सबमिट कर दे सर. बुक है जो.
यस सर.
मैं आज अपलोड करता हूँ, सब सबमिट कर दो. ओके, बाय सैटरडे यू कैन सबमिट.
सर सैटरडे तक सबमिट कर सकते ना.
चलेगा. I'll put that date, Saturday date. No problem.
Okay.
And I uploaded all the video lectures. Till yesterday I uploaded all the video lectures.
Thank you, sir.
Thank you, sir.